Question number 39. A photon of energy E and wavelength is scattered from an electron initially at rest, which means what? Electron is initially at rest. You have a photon. Photons are always moving, okay, which moves with the velocity of light, okay, and it also has an energy. What is the energy? Energy is equal to hf. We already know this. Hf is equal to energy over here, and it also has a momentum. What is the momentum? Momentum and energy are related by the equation P into C. Okay, now with this basics, let us start. So an energy of photon, a photon of energy E will come and strike this, and then what will happen? What is the energy of the photon and the wavelength of the photon? Both he is asking. When the electron moves away, when the electron moves away, so why does the electron move? Because photon gives some energy to it, right? Which means, let us say an energy, a photon has something like 10 electron volt, for example. When it comes here, let us say electron moves with an energy equal to 2 electron volt. What happens to the photon's energy? Photon's energy would become 8 electron volt over here, right? Which means energy is reduced. So energy of the photon reduces, right? Energy of the photon reduces. What is the energy of the photon? Energy of the photon reduces is lesser than E. Lesser than E. So this and this are right. These two are incorrect. Then what happens to the wavelength of photon? How do you find wavelength? See, E is equal to PC, right? E equal to PC. If E reduces, then automatically P also will reduce. When P reduces, we know that from the de Broglie's wavelength, P is equal to h by lambda, or lambda is equal to h by P. We can find out the wavelength from here. What happens to wavelength? When P reduces, lambda should increase. So which means it should be greater than the actual lambda. This should be your answer. Because here is less than lambda, this is also incorrect. So D should be your right answer.